pi to 0 and plus 1 in the interval 0 to pi. So we take this example and we'll find a Fourier series expansion for this. Okay, so minus 1 in the interval minus pi to 0. So here this example given f of x equals minus 1 in the interval minus pi less than x less than 0 and plus 1 in the interval 0 less than x less than 1. So here, less than pi. Okay, so here f of x plus 2 pi is f of x. So this function is periodic, and as I think we have defined last class, that is for any piecewise function given in the form f of x equals.
Good afternoon, sir.
Yeah, sorry.
Sir,
I got
if you're trying to share, if you're
yeah, I'm sorry. I'll share that. No.
We can't see the screen, sir.
Sorry. So because of hurry, I made a mistake.
You're not able to see the screen.
Now, can you view this PDF? Is it okay? Now, can you view this PDF in your system? Is the PDF is visible? Hello?
Yes, sir.
Okay, thank you.
You can see. Yeah.
Okay, so this is the example I would like to take. That means actually, go back to this PDF. We have defined previous class, that is for ordered even function of a given piecewise function. So how we can verify or how we can check whether it is a given function is odd or even. So I think last class we have defined with an example. Now let me take an example. Obtain Fourier series of the function f of x equals minus 1 in the interval minus pi to 0 and plus 1 in the interval 0 to pi. Okay, so that's same example I have taken. So now I go back to the previous what we defined. So if f of x is defined as like this, phi1 of x in the interval minus a less than x less than 0 and phi2 of x in the interval 0 less than x less than a. Okay, so the function is defined minus a to a. So that means it contains a negative interval. Now in this case I can easily verify just by taking phi1 and replace x with negative x. If I get phi2, positive phi2 of x, then the conclusion is that f of x is even. So I'm just collecting the definition I have given in the previous class, even function. If phi1 of minus x gives you negative phi2 of x, so then the conclusion is f of x is odd function. So this is what we have defined in the previous class. So now based on this, so here in the example, given example, so phi1 is, so here what is given phi1 of x is negative 1, okay, and phi2 of x is plus 1, that is 1. Now I just take this, I replace phi1 with minus x. So what I'll get, I just get a same, since it is a constant, it is minus 1 itself. So this can be written as minus into 1. In place of 1 we can write phi2 of x. So what do you get? Phi1 of minus x equals phi2 of, negative phi2 of x. So that becomes, the conclusion is the given function f of x is odd function. So we are getting an opposite sign, negative sign with phi2. So this function is odd function. Is it clear? So given function is odd. So since or else if you check the graph given in the PDF, so this graph itself, I can easily say that whether it is even or odd. See, you just see this part, it is symmetric about origin, not the y-axis. It is symmetric about origin. So from minus pi to pi, you just check this part, minus pi to pi. It is symmetric about origin. So that is, so just if you look into this part, so you can easily say it is symmetric about origin, so that it is an odd function. Or by calculations, you can easily verify that the given function is odd. I hope you have clear. So any doubt in this even and odd for a piecewise function? So now what we need to find is Fourier series of this f of x. So here, so given function f of x is odd, given f of x is odd function, so then the Fourier series expansion, the Fourier series expansion for an odd function is, so if it is an odd function, so what are the terms will be 0? The function is odd, what are the terms in the Fourier series will be 0? So that is cosine terms must be 0. So that means a0 and an both are zeros if it is an odd function. So if it is an even, only bn, that is sine terms are 0. So that means therefore f of x is, we get only sine terms, n running from 1 to infinity, bn sine 2n pi x by t, called as equation 1, where bn is, so the definition where bn is 2 by t, integration from c to c plus t, f of x into sine 2n pi x by t into dx. So now just integrate this and we can easily get the required Fourier series expansion for the given function. So here function f of x is given, period is 2 pi is given, okay. So with that, and c value is starting value minus pi. So with this substitute and simplify and integrate, you can easily obtain the required Fourier series. So now we'll see. So therefore a bn equals 2 by 2 pi integration from minus pi to pi f of x into sine 2n pi x divided by 2 pi into dx. Now just to recollect the definition. So f of x is odd function, so this is odd, and sine is also odd function. So their product of odd into odd is even. So their product is even. So that means for any integration from minus a to a, f of x into dx, if this is even, f of x is even, then this integration becomes 2 times integration from 0 to a f of x dx. So I can easily write for an even function instead of minus a to a f of x dx, I can just write 2 times 0 to a f of x dx. So I can make use of this result and I can reduce the simple calculation part. Okay, I hope it is clear. So now, since it is integrand is even.
Excuse me, sir.
Yes.
Sorry to interrupt. Can you, will the recording be saved on the MS Teams?
Yeah, now I am recording. You can
Uh,
download from your side also.
okay. Thank you.
So this 2 to cancelled. Now this bn becomes 1 by pi. So since this is a integrand is even and limits is minus pi to pi, so what we can write it as 2 times integration from 0 to pi f of x into sine, again 2 pi cancel, nx dx. So this 2 pi get cancelled.
Excuse me, sir.
Yes,
Sir, screen is not visible.
is it?
Yes, sir.
I'm sorry. Only this PDF is visible, huh?
No, sir, nothing.
No screen. Oh, I'm sorry. Again, I don't know how it is. Oh, okay. Now,
Sir.
now
Yes,
this
sir, no, it
PDF.
is. Yeah, yeah.
And okay, I'll just explain since from the beginning. Okay, so here again, this is not visible, not sharing, right? Is this screen is sharing?
Yes, sir, we can see.
With the white one, I mean, I have written something given f of x. Is this visible?
Yes, sir, we
Okay, thank you. Okay, so now I'll just start with the beginning part. So here given
Sir,
this one,
it went blank again, sir.
yeah,
we can't see it.
yeah, that was the problem again. So recording this. Someone has started the sharing the screen. Can you please don't share your screen? If you share the screen, uh, mute everyone. So someone is sharing the screen. I don't know who is that. So now, I hope you can view this screen now. So given f of x is minus 1 to 1, minus 1 in the interval minus pi to 0 and 1 in the interval 0 to pi. This example I have taken from the PDF that is provided you. I hope now you can view the screen. And this function is periodic function and its period is 2 pi. So as we see in the previous class, we have defined the odd and even function for a given piecewise functions. So that is f of x is equal to phi1 of x in the interval minus a to 0 and phi2 of x in the interval 0 to a. So this with this, that means x is defined in the interval minus a to a, and with that definition, so if you see that if phi1 of x, phi1 of negative x gives you positive phi2, then the function is even. Okay, if this phi1 of negative x gives you negative phi2, then the function is, it is called as odd. So now with this, what is given? The given is, it is phi1 is given as minus 1. Okay, so this is minus 1, phi1 is given. Similarly, phi2 is given as plus 1. So as it is given information, we have redefined as P2. Now what I will consider is in place P1, I just replace x with the negative x. Since Phi1 is minus 1, so if whatever I change with the variable x, it doesn't affect. So because it is a constant. And this minus 1 can be further written as minus into 1. So what is 1 actually? 1 is our Phi2. So minus times Phi2. And with the conclusion we get that Phi1 of negative x gives you negative Phi2. So that conclusion is it is odd function. So that is the given function is odd. So or else if you see the graph of this given PDF, again it is also symmetric about origin. So that means the graph of the function looks like in the interval minus pi to pi is like this. So with this, so here it is plus 1 and this is minus 1. So in the interval minus pi to 0. So in the 0 to minus pi you get a straight line, the value is minus 1, and in the interval 0 to pi we get again a straight line with the value 1. Constant function, not a straight line, sorry, it is a constant. So that is the, if you look into the graph, you can also easily say that it is symmetric about the origin. So symmetric about origin, so it is an odd function. So now with this, first we can find, since we need to find a Fourier series expansion, so here the definition of Fourier series for an odd function is it contains only sine terms. That means we can have the a0 and an are zeros. So that is f of x is equal to summation n from 1 to infinity bn into sine 2n pi x by t, we call it as equation 1, where bn is defined as 2 by t integration from c to c plus t. So integration from c to c plus t f of x into sine 2n pi x by t into dx. So given that period is 2 pi, given that period t is 2 pi, and the value of lower limit, that is lower limit is c and its value is minus pi. So here further with that given information I can say that bn is 2 by 2 pi integration from minus pi to pi f of x into dx, f of x into sine 2n pi x by 2 pi into dx. So as we seen just now, f of x, given f of x is odd, and sine of x is again, sine x is also an odd function. Sine x is odd, so here we have product of even and odd into odd. I'm sorry, product of odd into odd is even. So integrand, now the integrand is even, and if the integrand is even, as is another definition, that is integration from minus a to a f of x dx for an even function can be written as 2 times integration from 0 to a f of x dx. So this is also a known result. So with that information I can write bn equals 1 by pi into, so since it is minus pi to pi we are writing, and for an even function it is 2 times 0 to pi, f of x sine 2 pi cancel, sine n x into dx. So now, so that is, if you see, it is f of x defined in the interval 0 to pi is 1. So that becomes bn is equal to 2 by pi integration from 0 to pi, where f of x is 1 into sine n dx. So simply integration of sine nx. So integration of sine nx is minus cos nx divided by n limits from 0 to pi. So substitute the upper and lower limit. we get negative minus 2 by pi n, so n is also constant. Upper limit is cos pi n pi and lower limit is minus cos 0. Okay, so this becomes Bn equals minus 2 divided by n pi into minus 1 power cos n pi value is minus 1 power n minus cos 0 is 1, or I can take that negative inside, so this becomes 2 divided by n pi into so minus into minus plus 1 into minus 1 power n. Okay, so that is further we can easily notice that, so this value, the value of 1 minus 1 power n, so this value is, it is 0 for even n values, and it is 2 for odd n. You know, when you put odd n, that means n is equal to, when you put 1, 3, 5, when n equal to 1, we get minus 1, minus into minus plus 1, so we get total is 2. When n is even, for example, even in the sense 2, if you take 2, so minus 1 square is plus 1, so 1 minus 1 is 0. So this is also another result. So right now, so we get Bn is 2 by n pi into 1 minus 1 power n. So now substitute this in equation 1. So equation 1 implies, so that is equation 1 implies so 1 implies f of x equals summation n running from 1 to infinity Bn, that is 2 divided by n pi into 1 minus 1 power n into sine nx. So 2 pi get cancelled, is the required Fourier series. Suppose if you wish to expand the summation, so this will be 4 divided by pi into, so when n is equal to 1 we get 2, so that is sin x. When n is equal to 2 we get 0 plus sin 3x divided by 3 plus n equal to 5 sin 5x by 5 plus, and so on, we get the required Fourier series expansion of a given function in the interval minus pi to pi. So this is a simple example, and the next example is, I think we have defined the function f of x is equal to mod x. So this definition, mod x, is taken in the previous class itself. It is minus x in the interval, say minus a less than x less than 0 for any value of a, and x in the interval 0 less than x less than a. So x belongs to an interval minus a comma a. So it is a mod x function, and we got Fourier series expansion for a mod x function, and since it is just another way of representing as a piecewise function, so the next example I will not discuss that example. Okay, so that is you can go through that. I mean, as a example, this is similar to example 3. The result of 5 is same as example 3, and I don't take this again. So let me take one more example, that is the sixth one. F of x is equal to 2 times 1 plus x in the interval minus 1 to 0 and 0 in the interval 0 to 1. So f of x, next example, given f of x is 2 times 1 plus x in the interval minus 1 less than x less than 0 and 0 in the interval 0 less than x less than 1. Is that correct? Yeah. So f of x plus 2 is equal to f of x. So now this example, can anyone tell whether it is a even or odd, or neither even nor odd? Is it even or odd? Anybody? Please try to answer this question. Is the function is even or odd? Okay, sorry. Again,
It's
it is
neither
not.
even nor odd, sir.
I think it is not shared again. So someone is it shared? The screen?
Yes,
Is
sir,
it?
we can see this.
Yeah, thank you. So neither even nor odd is the correct answer. So that is, if you see here, whatever phi1 of x, for example, so if I write phi1 of x as 2 times 1 plus x and phi2, so here phi2 of x second function is 0. Since phi2 is constant, phi2 is constant and whatever I replace with phi1, I won't get back to the phi2 because phi1 is a function of x and phi2 is constant. Whatever you replace negative x or anything, you won't get back to 0. So that is the reason I can easily say this function is neither even nor odd. So it is the function neither even nor odd. So now I have to write Fourier series full expansion and I need to find A naught, An, Bn. Three terms I need to find. So therefore the Fourier series is f of x equals A naught by 2 plus summation n from 1 to infinity an cos 2 n pi x by t plus summation n from 1 to infinity bn sin 2n pi x divided by t, so called as equation 1, and we have where a naught, an and bn are defined. So a naught is 2 by t integration from c to c plus t f of x into dx, and an is, it is 2 by t integration from c to c plus t f of x into cos 2n pi x by t into dx, and similarly bn, just now we defined bn, that is 2 by t integration from c to c plus t f of x into sin 2n pi x by t into dx. So with this I need to find a naught with the given f of x, and I need to find a naught an and bn. So f of x is just defined in the interval minus 1 to 0. So 0 to 1 it is 0, so no need to find the no need to evaluate integration in the interval 0 to 1 since it is 0, and period is given as 2. So using this I can easily obtain a naught on an and bn. So a naught is 2 by 2, 2 by 2, integration from it is minus 1 to 0 f of x into dx. So actually it is minus 1 to 1. Let me write minus 1 to 1 first, and then I can replace with I can separate the integrals. So 2 to cancel, it is integration from minus 1 to 0 f of x dx. Since f of x is piecewise function, we need to split the integral as minus 1 to 0 and 0 to 1 f of x dx. So this, since in the interval 0 to 1 it is 0, okay, and minus 1 to 1 we have the given function, it is integration from minus 1 to 1, minus 1 to 0, it is given that 2 times 1 plus x into dx. So that is, I can take 2 common, 2 outside, integration of 1 is x plus integration of x is x square by 2, limits from minus 1 to 0. So substitute that limit, we get a naught is 2 into upper limit is 0 anyhow, it won't change, upper limit is 0 minus lower limit. So lower limit is minus 1 plus minus 1 square by 2. So that becomes 2 into, so negative 2. So minus 1 plus 1, minus 1 square is 1 by 2. So minus 1 plus 1 by 2 is minus half. So minus 2 into minus 1 by 2. So we get 1. So a naught value is 1. Okay, then I need to find an. So an is 2 by t, 2 by 2, integration from minus 1 to 1 f of x into cos 2 n pi x by 2 into dx. So 2 to cancel. Okay, so now I can, since f of x is piecewise function, I can redefine as minus 1 to 0 f of x. So minus 1 to 0 it is given as 2 times 1 plus x into cos 2 n pi, sorry, no 2, only n pi x. So no 2, so 2 to cancel, it is n pi x into dx. And next term is 0, I can directly write 0 because in the interval 0 to 1 is 0. So here is first function into second function. So an becomes 2 is constant, we can take outside. First function is 1 plus x into integration of second is integration of cos is sin n pi x by n pi minus derivative of 1 plus x is 1 into integration of sin is minus cos n pi x divided by n pi whole square, limits from minus 1 to 0. Okay, so use upper and limit and lower limit. So just calculate what will be the sin upper limit. So sin 0 is 0, and when sin of minus n pi, so x is equal to minus 1, sin of minus n pi is nothing but minus sin n pi. So what is sin n pi value? Since n is an integer, so sin n pi value is again 0. So both upper limit and lower limit, this gives you 0. So only remains is only one term, non-zero term. So that becomes So minus into minus plus, so here we have a negative sign and this is a negative sign, it becomes plus, and 2 divided by n pi whole square into, put an upper limit cos 0 minus lower limit cos of minus n pi. So cos of minus theta is cos theta, and after simplification this becomes 2 divided by n pi whole square into cos 0 is 1 minus cos n pi value is minus 1 power n. So is the required an. So now we need to find bn. So bn is 2 by t, that is 2 by 2 integration from minus 1 to 1 f of x into sine 2n pi x by 2 into dx. So now 2 to cancel, and the function is piecewise, so that is, this can be written as integration from minus 1 to 0 f of x is 2 times 1 plus x into sine n pi x dx plus 0, because next term is 0. So that becomes bn is 2 is constant, again first function, that is 1 plus x into integration of sine is minus cos n pi x divided by n pi minus derivative of 1 plus x is 1 into integration of cos is minus sine n pi x by n pi square. So limit from minus 1 to 0. So again now we need to check we can easily compute that upper limit and lower limit. So if you see sine 0, upper limit sine 0 is 0, and again lower limit sine of minus n pi is again 0. So both the terms, both the upper and lower limit, the second term will be 0. So we get only the first term, so that becomes minus, so negative is constant, I take outside, I'll put upper limit. So this is 1 plus 0, 1 plus 0 is 1 into cos 0, okay, and minus lower limit is minus 1. So minus 1 minus 1 into cos n pi. Okay, so 1 minus 1, this is 0, and we get bn as minus 2. Not minus 2, it is divided by n pi. So what is that? Whole divided by n pi. So that term we have missed. So minus 2 divided by n pi is bn. So with whatever given, whatever obtained a0, an, bn, we substitute into the equation 1. So equation 1 implies f of x equals a0. So just now we got a0. So what is that a0? a0 is 1, an is 2 by n pi whole square into 1 minus 1 power n, and that is a0 is 1, so 1 by 2, a0 by 2 plus summation n from 1 to infinity, an is 2 divided by n pi whole square into minus 1 power n minus 1 cos, so 2 to cancel, n pi x, and then plus summation n running from 1 to infinity, bn, that is minus 2 divided by n pi into sine, we have n pi x. So is the required Fourier series expansion for the given function. Any doubt in this example? So please note down this simultaneously when I solve. So if you get any, if you are stuck at somewhere, we can help you. So I'll take your attendance. So now we have actually in this given notes, so we got we have only one example remains, f of x. So I'll take tomorrow this and I'll finish the Fourier series in the next class, and we start another type of Fourier series. Let me see in the next class. Okay, I think okay. So any doubt? If you have any doubt, let me discuss. Okay, I just want to announce you from today's class. I'll take your attendance manually also. So just once I start the classes, exactly 10 minutes after I start the class, 10 minutes I'll take your attendance, and that will be the final. You can also view your attendance. So from tomorrow onwards I'll follow that. Okay, so that's all today's
Sir,
class.
also, I had a doubt, sir.
Yeah, sure.
How do you have this calendar on MS Teams, right?
Yeah, I have a calendar. Yes.
How do we access it as well?
You're asking for your point of view, or
Yes, yes, our point of view, because we don't have the calendar on MS Teams.
this so this is actually since you're not using the someone here, I just noticed. Yeah, Dikshita. Dikshita can now Dikshita can view the calendar. Except Dikshita in this list, I don't think no one. Yeah, don't think except Dikshita, no one can view this calendar
But why, sir?
because you have not logged in
No,
MS.
half
Yeah,
of them are logged in. Even I'm logged in through MS Teams.
sorry, pardon.
Even I'm logged in through MS Teams.
Okay, you cannot view calendar in your app in
No,
your
sir.
login?
Nope.
I mean, not you are not able to review calendar of any other subjects, not only mathematics.
No, sir.
So then, because what I know is those who logged in MS Teams, so through the